Hello everyone. So today is Wednesday, April 22nd. We are going to continue with adding and subtracting radicals. Yesterday, when you added and subtracted radicals, either the radicands were the same, so all you had to do was add and subtract the coefficients, or one of the radicands was unlike, where you had to simplify that one, and then you can combine everything together. Today, we're going to be working on problems where both radicands are different, and we're going to have to simplify both of them in order to be able to combine them together. So for the first example that's already done for us, we see we have radical 18 plus radical 32. So right now, these are not like, so there's nothing we can do with them. So we need to simplify both of them. So 18 has a greatest perfect square factor of 9. 9 times 2 gives me 18. Now the fact that I'm going to be using a factor of 2 lets me know when I factor my 32, I should also probably have 2 as a factor. And 32 can simplify to radical 16 radical 2. I take the square root of my perfect square, which would be 3 radical 2, bring down my plus sign. I take the square root of my 16, which is 4, bring down my radical 2, and now I can add these together because my radicals are the same. So 3 radical 2 plus 4 radical 2 would be 7 radical 2, because 3 plus 4 is 7. So looking at example number 8. So I have radical 48 minus radical 27. So radical 48, I can simplify that to radical 16 radical 3 minus. Now the fact that 16 is my perfect square, I know that 3 is going to be my radicand. So I'm going to use the fact that 3 is my non-perfect square and see what happens when I divide 27 by 3. When I divide 27 by 3, I get 9, which is great because 9 is a perfect square. So my factors of 27, one is which is a perfect square, would be 9 and 3. So now I'm going to take the square root of my perfect square. So the square root of 16 is 4, bring down my radical 3, minus the square root of 9 is 3, bring down my radical 3, and now my radicands match, so now I can subtract them. So 4 minus 3 would be 1 radical 3, or since it's only a coefficient of 1, you can just write it as radical 3. Those are equivalent to each other. All right, example number 2. So we have 2 radical 80 plus radical 45. So I know most of us think of 10 as a factor of 80 right away, but the problem is that 8 is not a perfect square. So what you need to do is you need to think of other factors of 80, like 5, and see what the other factor would be. And the way you can do that is just by taking 80 and dividing it by 5. So if I divide 80 by 5, I get 16, which is great because 16 is a perfect square. So I'm going to rewrite 2 radical 80 as 2 radical 16 radical 5 plus. Now the fact that 5 is my non-perfect square is a clue that I want to figure out what multiplies with 5 to give me 45. And that would be 9, which is perfect because 9 is a perfect square. So now I'm going to break down 45 into radical 9, radical 5. Now we'll take the square root of our perfect squares. So 2 radical 16 radical 5, I take the square root of 16, which is 4. So now I'm going to have 2 times 4 radical 5 plus the square root of 9 is 3 radical 5. We have to multiply together 2 and 4 first, which would be 8 radical 5 plus 3 radical 5. And now we can add these together. 8 plus 3 would be 11 radical 5. All right, so now I'd like you to do the practice problems on the next page. And when you are done, just make sure you submit it to me. Any questions that you have, just make sure you send me an email or just send me a comment.